The definition of precision oncology has been changing over time. About 5-6 years ago, it meant the use of targeted therapies, therapies like Gleevec or Herceptin. In about 2012, what precision oncology largely referred to was the use of biomarkers to decide which patients should receive which drugs, such as the use of ALK to decide who should get crizotinib. But more recently, over the last year, precision oncology increasingly means the use of next-generation sequencing or other types of omics to define who should get treated with off-label anti-cancer drugs, patients with a wide variety of cancers. So I think that the changing definition of precision oncology is part of the challenge in terms of making sure that it works and that it's promising. The other thing I talk about is the data that it works. And I think, sadly, data that precision oncology is a viable strategy is still lacking. We lack large-scale randomized trials showing benefits of this strategy over alternative strategies. And finally, I talk about the likelihood precision oncology will succeed. And I think there are a bunch of reasons why we should be cautious of this approach. Foremost, if you look at the landscape of cancers and the amount of mutations present in a cancer, you find that cancers have on average between 2 and 8 mutations per every 1,000 DNA bases, which when you look across a whole cancer cell is a lot of mutations. And precision oncology is this idea that we're going to look in this sea of mutations and pick just 1 or perhaps 2 mutations that we know that we have drugs for and to drug those mutations. I think fundamentally that may be implausible at the outset. So I think we should be cautious about the biological rationale as well. And those are really the 3 main pillars of my talk.